All right, today we are diving headfirst into one of the absolute biggest mysteries in all of physics, the double-slit experiment. But, we're not just going to rehash the same old story. We're going to explore a really fascinating and yet pretty controversial mechanical solution from a researcher named Miles Mathis. So let's just jump right in. For almost 100 years, we've been told that the quantum world is just, well, it's spooky, right? It's weird, it's totally counterintuitive. But what if it's not? What if all that strangeness is just a big misunderstanding? What if there's a simple, physical mechanism that's been staring us in the face this whole time? That's the big question we're tackling.
Okay, so to really get a grip on this new idea, you've got to understand just how huge this problem is. This isn't some newfangled puzzle. We're talking about a foundational paradox that has completely stumped some of the smartest people on the planet for a very, very long time.
So here's the crazy part. You fire a single particle, like one photon all by itself, at a wall with two slits in it, and somehow it acts like a wave. It seems to go through both slits at the same time and then interferes with itself on the other side. How does that even work? How can one thing be in two places and interfere with itself? It makes zero sense in our everyday world, and that right there is the paradox that's been driving physicists nuts.
And get this isn't some new quantum discovery. The first guy to do this experiment, Thomas Young, did it way back in 1801. That's over 200 years ago. So we've been scratching our heads over this for centuries. Think about everything that's happened since then. We went from horse and buggy to landing robots on Mars. And this one simple question, still stubbornly unanswered.
Now, of course, scientists haven't just been sitting around doing nothing. There is an accepted explanation out there. But it's an explanation that a lot of people, including Miles Mathis, find really unsatisfying. Why? Because it's not a physical, mechanical explanation. It comes from the legendary Richard Feynman.
So the great Richard Feynman came up with this brilliant mathematical way to deal with it. It's called the sum over paths. And it basically says, well, the particle doesn't take just one path in a weird, probabilistic way. It takes every possible path all at once. The math is beautiful. It works perfectly for predicting where the particle will land, but it doesn't actually tell you what is physically happening. It's a description, not an explanation.
And that's really the heart of the disagreement right there. Feynman's view is all about math, about a field of probabilities. It's great at telling you what is going to happen, but Mathis comes along and says, hang on, that's not enough. He argues that physics is supposed to explain how things happen, with real physical stuff, not just abstract equations.
Yeah, Mathis's whole point is that probabilities don't just pop out of thin air. They have to be caused by something real. And his argument's pretty clever. He says the fact that Feynman's math works so well isn't a reason to stop looking. No, it's actually proof that there must be some undiscovered physical field out there that's creating those very probabilities.
So, what is this hidden physical thing he's talking about? Well, that brings us right to the core of his solution. Mathis's big claim is that everyone who's ever looked at this experiment has missed something huge, something obvious. We're always so focused on the little photon we're shooting and the tiny slits it goes through. But what about the single biggest object in the whole setup? What about the wall? Okay, let's walk through his logic step by step. It's actually pretty simple. 1. The wall is made of matter, right? Atoms and stuff. 2. Mathis proposes that all matter, everything, is constantly radiating a field of tiny, real particles. 3. And this is the absolute key. The two slits in the wall cause that radiated field to create its own interference pattern. So by the time you fire your photon, the pattern is already there. The photon isn't interfering with itself, it's just getting guided by the invisible channels that already exist in this field. And that is the punchline. The interference pattern has nothing to do with the spooky quantum photon. It's just a normal, physical feature of the field coming off the wall. The pattern is already there before you even turn the machine on. Your photon just comes along and reveals it. It's like following a path that's already been laid down. So, Mathis actually gives this field a name. He calls it the B-photon field, and he thinks of it as this foundational electromagnetic field made of real actual particles, B-photons, that all matter is constantly spitting out. And the reason we can't see it? Well, our instruments just aren't built to detect it. But even if it's invisible to us, he says it's physically there, and it's interacting with all the bigger particles we can see. To make this whole idea a little easier to picture, Mathis uses this fantastic analogy. Just imagine the B-photon field is like a huge, dense sea of tiny little golf balls. The two slits in the wall create an interference pattern in that sea, like little channels and ridges. Now, the photon you fire, that's like a much bigger baseball flying through. The baseball isn't doing anything weird or spooky. It's just getting funneled and guided by the pattern that's already there in the sea of golf balls.
Okay, so that seems to explain the basic interference pattern pretty neatly. But what about the other part of the mystery? You know, the part that's arguably even spookier. Why does the whole pattern disappear the moment you try to watch which slit the particle goes through?
Right? This is the bit that leads to all those crazy ideas about consciousness changing reality. The very act of observing seems to force the photon to pick a side, act like a normal particle, and poof, the interference pattern is gone. So how does a purely mechanical model like Mathis's explain that?
Well, his answer is, it has absolutely nothing to do with us looking at it. Zero. It's not about consciousness, it's just more mechanics. Think about it. A detector isn't some magical passive eye. It's a piece of physical hardware, and for it to detect anything, it has to interact with it, which means it has to be emitting its own powerful field.
So now you've got two different fields messing with our photon. You have the Walls field, which is subtle, creating that nice, delicate interference pattern. But then you stick a detector in there, and its field, which has to be strong enough to actually, detect something, is way more powerful. Let's go back to the analogy. If the Walls field is made of golf balls, the detector's field is like a storm of bowling balls. It's just a much, much stronger force. And the result is, well, it's pretty straightforward. The powerful bowling ball field from the detector just completely overwhelms and washes out the subtle golf ball pattern from the wall. It just erases it. So our photon, our baseball, isn't being guided by that complex pattern anymore. It's being pushed around by the detector's much simpler field. And just like that, the interference pattern disappears. No magic, no spooky action, just one field overpowering another.
But look, a cool theory is one thing. To be real science, it can't just explain old puzzles. It has to make a new prediction, something you can actually go out and test. And Mathis proposes a really clever one, a prediction that he says the standard model would have absolutely no way to explain.
Okay, you gotta hear this. He suggests a new experiment. Instead of shooting a particle through the slits, you shoot it at the solid part of the wall so it bounces off and reflects back towards where it came from. Now here's his prediction. He says you will find an interference pattern on a screen back at the start. Why on earth would that happen? Well, in his model, the wall with the slits is radiating its field in all directions, forwards and backwards. So the photon that bounces back would get funneled by that field on its trip home. Current quantum theory has absolutely no explanation for why that would happen. None.
And so that leaves us with this really big, fascinating question. For decades, we've just accepted that the quantum world is fundamentally weird and spooky and random. But what if we just missed a piece of the puzzle? Could a simple, physical, mechanical field, a kind of hidden reality, be the real reason for all the strangeness we see? It's definitely a provocative thought to chew on.